High above us, further than any rocket has ever gone, orbits a telescope unlike any other. This is the James Webb Space Telescope, or JWST for short. It's a marvel of engineering, with a giant mirror that collects light from the furthest reaches of the universe. Its mission, to peer back in time to the very first stars and galaxies that formed after the Big Bang. Imagine looking at a baby picture of the universe. That's what JWST allows us to do. But it's not just about looking at pretty pictures. It's about understanding how everything we see today, from the planets to the stars, came to be. JWST can see light that our eyes cannot, infrared light. This is important because when we look at the very distant universe, the light from those objects has been stretched by the expansion of the universe. This stretching shifts the light into the infrared portion of the electromagnetic spectrum. One area of the universe that JWST has been studying is the Serpens Nebula. Located about 750 light-years away from Earth, it might seem like just another pretty picture of glowing gas and dust. But don't be fooled. This nebula is a stellar nursery, a place where stars are born. Think of it like this. Imagine a giant cloud of gas and dust, many times larger than our entire solar system. This cloud is cold and dark, but within it, gravity is at work. It slowly pulls the gas and dust together, like a sculptor molding clay. As more and more material clumps together, the temperature at the center of this collapsing cloud begins to rise. Eventually it gets so hot and dense that nuclear fusion ignites, and a star is born. Now, let's zoom in on a specific image captured by JWST's near-infrared camera. This image shows a region within the Serpens Nebula where new stars are bursting into existence. In the image, you can see these bright jets of light shooting out from the center of the collapsing clouds. These jets, called protostellar outflows, are crucial to the star formation process. Imagine a spinning figure skater pulling their arms in. They spin faster, right? The same principle applies to these collapsing clouds of gas and dust. As they shrink, they spin faster, and this spinning creates a magnetic field. The magnetic field channels the material falling onto the young star, directing it towards the poles. It's like a cosmic fire hose blasting out jets of material at incredible speeds. These jets carve out cavities within the surrounding gas and dust, creating the spectacular structures we see in the JWST image. The process of star formation is a delicate balancing act between gravity, which wants to pull everything together, and the outward pressure from the heat and light of the newly forming star. It's a battle that can last for millions of years. As the young star continues to gather material from its surroundings, its core gets hotter and denser. Eventually, the temperature and pressure at the core becomes so extreme that hydrogen atoms are forced to fuse together, creating helium and releasing enormous amounts of energy. This is nuclear fusion, the same process that powers our sun. Once nuclear fusion ignites in the star's core, it establishes a balance between gravity, pulling inward, and the outward pressure from the star's energy. The star enters a long, stable period of its life, shining brightly for millions or even billions of years. The observations of the Serpens Nebula, with its clear view of aligned protostellar outflows, provide strong evidence for the role of angular momentum in star formation. Angular momentum is a measure of how much an object is rotating. Before JWST, we had glimpses of these outflows, but they were often obscured by the surrounding dust. With its ability to see through this dust, JWST provides us with the clearest views yet of these early stages of star formation. These observations are not just about understanding star formation. They also give us clues about the formation of planets. The material in those protostellar jets could eventually clump together to form planets, asteroids, and comets. So, by studying these jets, we are also learning about the very building blocks of our own solar system. The James Webb Space Telescope is more than just a telescope. It's a time machine, a cosmic storyteller, and a window into the vastness of the universe. Its journey has just begun. And with each new observation, we are one step closer to uncovering the universe's greatest secrets. The mysteries of the cosmos are waiting to be unraveled. As JWST continues to peer deep into the universe, it will undoubtedly reveal even more breathtaking images and groundbreaking discoveries inspiring future generations to keep exploring the wonders of the cosmos.